everyone, welcome to today's video on identifying functions. So today we're going to define what a function is and then see lots of examples of functions and relations that are not functions. So a relation is a function if for each input there is exactly one output. And that's a phrase you should really try to get in your head that's going to constantly be our explanation for what makes something a function versus something that's not a function. And what it means kind of generally, if we think about it, for each input, so when we're doing something, we input something, we choose some number, we press something, there's exactly one thing we get as a result of that. There's not multiple options for the same input. And that's helpful. It's helpful in the world, an idea of a function, because we often want one particular thing. In my class, I normally talk about a vending machine, where when we press a button on a vending machine, we only want one snack to come as a result of that. We don't want there to be this like mystery and surprise where there's multiple different outputs or snacks. We just want one thing, and we choose our input so that we only get that exact output, right? So functions are very useful in that sense in the world because we're trying to get the thing in particular that we want. If you're thinking about a video game or a phone, when we press a particular button, we want there to be only one thing that's going to happen. It's not good if when you press the right button, sometimes you go right and sometimes you go up. Right? So even though that situation, if you press the right button, there's two possible results, that's a relation. It's a relationship between two sets of values, in this case, the button you're pressing and then what happens in the video game. But we don't want there to be two different outputs. We want there to be only one. Okay, so we're going to be looking in order to identify when we have a function under the general category of a relation, just a relationships between two sets. Okay, we'll be focusing on the input and the output. So when we're talking about points, an input is going to be the x values. The x is our independent variable. In word problems, what we can control. And then the output, the y, is the dependent variable, like what happens as a result. Okay, so this is just like a little picture. Some of the vocabulary is less important. But we're going to think about inputs, x's. Then we have some relationship, and often a function, that's going to give us outputs, right? We'll see the word domain and range sometimes. You'll see that more in high school. Also independent variable and then dependent variable, right? So we have some starting, a relation, or in particular sometimes a function will then give us the outputs. So an example of a function is over here on the right. Each input corresponds with exactly one output. This is called a mapping diagram. So on the left-hand side, we have our inputs, and on the right-hand side, we have our outputs. Okay, so if I have an input of 1, I put in 1, I press 1, that's my starting value. I'm going to get a 2 in this case. Okay, when I have an input of a 3, I get a 7. When I get an input of an 8, I get a 9. A 7, I get a 14, and a 5, I get a 21. For each input, there is only one output that I'm going to get. Okay, so thus that is a function. Okay, but then if we go over here, this is a table representation of a relation. We see that this is not a function because one input is assigned two different outputs. So when we press 2, sometimes, I mean, it's not press necessarily, but that can be a way to think about it with like a vending machine or a machine. We input 2, we give 2. Sometimes we're getting 4 and sometimes we're getting 6. Okay, so there's two different outputs for that same input. So that relation is not a function, right? When we're graphing, we can look at the graphs of relations and identify whether the graph represents a relation that's not a function or a function. Okay, and the way that we do that quickly and easily is called the vertical line test. The vertical line test asks us to draw vertical lines, which go up and down, anywhere along the graph. Okay, and if at any point that vertical line crosses our graph 2 or more times, then it's not a function. Okay, but if any line, no matter what vertical line we can draw, no matter what up and down line we can draw, or the line is only going to cross our graph at one point, like we have in this case, we say it is a function. Now, this is kind of like a test. I want to make sure we see the connection, though, between why this test works and the definition of a function. Okay, so a function, again, says that for each input, there's exactly one output. Okay, so if I were to give this point, we're going to give this an x value of 3. Right here, it's my x-axis. This is an x value of 3. And then I'll give this a y value of 4, and this a y value of negative 4, for example. Totally made up numbers. This is the point 3, 4, and this is the point 3, negative 4. Thus, in this situation, I have the same input of 3. I have the same x value of 3, and I get 2 different y values, negative 4 and 4. Thus, this is not a function because for the same input, there's 2 outputs. And the vertical line in this case is showing that, right? But over here in this function situation, we'll just make this point 3, 4, 2. Okay, this is the point 3, 4. For the input of 3, there is only one point along that vertical line, so there's only one y value. Right, so that one is a function. Okay, using that, let's just look at some examples. The top one is a version we haven't seen so far. This is just listing out the coordinate points in, this is called like set notation. Okay, when we put the little squiggly brackets. In these situations, we want to compare the x values, the inputs, and the y values, and see is there any x value input that corresponds then with 2 different outputs, y values. Okay, so in this situation, I have negative 3, 4, negative 2, 4, negative 1, 4, 2, 4, and 3, 4. Okay, so this is a function, and a lot of people will get confused here, and they'll say this is not a function because we have the repeating y values, we have the repeating outputs, but that is not how a function is defined. A function means for each input, for each x value, there's only one y value that it corresponds with. So negative 3 only goes to 4. There's no other negative 3, it's not negative 3, 4, negative 3, 6. We only see negative 3, 4. Same thing here. For the input of negative 1, we only have the output of 4. For the input 2, we only have the output of 4. And for the input 3, we only have the output of 4. So for each input, there is exactly one output. Okay? That's what we have in this situation. Thus, we have a function. So now let's look at our other ones. Here we have this circular graph. Okay, this fails the vertical line test. I could do it almost anywhere. We'll go here. Okay, here's a vertical line. And this vertical line crosses my circular graph here at 2 points. So the same input of negative 3 has 2 different outputs. So then this is not a function. It fails the vertical line test. For some input, there is more than one output. Now we see this mapping diagram. Okay, in our mapping diagram, let's look at our inputs. 10 goes to 15 only, that's good. 20 goes to 45 only, that's good. 30 goes to 25 only, that's good. And 40 goes to 35 only. So for each of those 4 inputs, there is only one output, so this is a function. And then finally, let's look at our table. For our table, we have an input of 2, that goes to 20. 4 goes to 40. 3 goes to 30. And then we have 2 again. Okay, so 2 is going both to 20 and to 40. So this is not a function. And we would explain that because for the input of 2, there are 2 outputs. Right? The input of 2 has 2 outputs it's mapped to 2 different outputs, so it's not a function. Okay. All right, take a look at yourself for these U-tries. So first we'll do the graphing one, so give this a try first. Okay, is this graph representing a function? Are these relations a function? So try number 1 first. Yes, number 1 is a function because it passes the vertical line test. No matter where I draw a vertical line on this graph, it's only going to cross the graphs once. Right, so that is a function. For each input, there's only one output. Now try our table 2. Is the relation represented in the table a function? Yes, 2 is a function. For each input, there is exactly one output. Okay, now try 3. 3 is not a function because we have 0 and 4 and then 0, 8. Okay, so we have the input of 0. 0 has 2 different outputs. Okay, so that makes it not a function. And 4 here, does this represent a function? Yes, this does represent a function, and that's important because often this is the kind that people get confused about. Okay, this is a function. For each input, 1, it goes to -2. For each input 2, it goes to -2. 3 goes to -2, and 4 goes to -2. For each input, there is only one output, right? It is this output of a -2. So it's fine that they all go to -2. That goes back to this example, right? It's fine if inputs have the same output. It really comes back to the question of, and the idea of like, whenever I press the 2 button, do I know what I'm going to get? Yeah, every time I press that 2 button, I'm going to get an output of a -2. So this is a function, right? The case where it wouldn't be a function in a mapping diagram is if I have like 1, 2, 3, 4, 5 here. If 1 goes to 3 and it goes to 4, there's 2 arrows like that, then this is a case where I do not have a function, not a function. Because sometimes when I press 1, I get a 3, and sometimes when I press 1, I get a 4. Okay. So don't forget, main idea to get in our heads is that the definition of a function is for each input, there is exactly one output. Whenever I have that input, I know exactly what I'm going to get as my output. Okay, great job, everyone.